Hey, physics kids, here's a little bit of help for basically question number 7. So we've got a projectile which has a mass of 5.5 kilograms. It's fired from the ground with an initial velocity of 169 meters per second at an angle of 23 degrees above the horizon, and at some time later, again lands on the ground. So it's asking for a bunch of questions here, all stuff that we've done before. So I want to make sure that we go through it. So it's asking first for the velocity of the projectile at its highest point. So a couple things we need to consider. Number one, here's what the situation looks like, where this thing got shot out at 23 degrees above the horizon at 169 meters per second. In the x direction and the y direction, and also combining all the velocities, we have a bunch of different things. So this is the combined velocities, and then we also have from here to here would be the vertical or the y velocity, and then from here to here would be the horizontal or the x velocity. Some things that we know as well: the acceleration in the vertical direction is always negative 9.8. We're going to assume that there is no friction, so that there is no acceleration horizontally. And so if we answer this question, what's the velocity of the projectile at its highest point? Vertically it's 0. Horizontally it would always be 155.56, and we did some trig to get there. And so yeah, there's kind of that first answer. All right, if we take a look at B, what will be the total flight time of this projectile? I think we needed to use probably this equation to figure it out, or this one. So we broke up the problem into the stuff that we know. We talked about the accelerations already. The initial velocities we figured out using trig. And then the final velocities, if it was shot straight up at 66.03, then by the time it got back down, it would also be that same value except negative. And horizontally, it will always be the same. We don't know how long it's in the air for. Initially, the displacement is 0 because it's on the ground. Okay, so I'm going to change that to a final. Sorry. Okay, so actually the easiest thing to use right away is actually the velocity final equation. It's asking for the total flight time. I know when it comes back to the ground, it will end up actually having a negative 66.03 meters per second value, and the reason it's negative is because it's moving down. Its acceleration due to gravity is negative 9.8. How long is it in the air for? We don't know. It initially got shot up with that value, and so if we solve that for t, that will take 13.47 seconds. All right, next, what will be the height of this projectile at the highest point of its trajectory, or to try to find a final distance? And again, we're going to stick with the vertical stuff because it's asking for a height. So we've reduced some of this stuff down where we've got negative 9.8 times a half, which is that value. The time is 6.735. The reason why we have this is because if it takes this long, 13.47, to go up and down, it'll take half that time to just go up. And that's what's happening, is that's going to go up. And then we're going to square that, and that's going to be added to the initial velocity times, again, the time it's going to be in the air for, which is going to be just as it's rising, and then its initial displacement off the ground was 0. So if we solve, we end up getting 222.44 roughly meters. All right, the range of this projectile is how far it will eventually go. And again, now we're going to be using the horizontal information as much as we can. Horizontally, we know that its acceleration due to gravity is 0, so that can all be wiped out. The velocity initially is 155.56, and it's going to be totally in the air for 13.47 seconds, and it had no initial displacement. So if we reduce that down, it'll be about 2,000 meters. All right, what will be the vertical velocity of the projectile? 3.5 seconds after it has been fired. So yeah, we just rock that through. That's a fairly easy equation. All right, horizontal velocity, that's a conceptual question. It will not change. All right, G is a little bit more difficult question. If we combine those two values where it's still moving 155.56 meters per second, but now instead of a velocity of about 61, it now has a velocity of 31.73. What's its new direction and magnitude? So we'll use the Pythagorean theorem to solve for this side, and we end up getting 158.2. And then we're going to use the inverse tan function to end up finding the angle measurement, which the angle measurement here is 11.52. However, we want to know where its actual direction is at. So it's above 90, or it's actually 78.48 degrees. All right. Solving this problem will be the height of the projectile. There we go. We use the DF equation again. Again, what's its range? We use the DF equation except for the horizontal point here, and we get 544.46. And don't do J. So there we go.